section 4.1 of the guided notes. We are going to be adding and subtracting polynomials in chapter 4, and eventually this is going to lead us into further work with polynomials, but we have to be able to add and subtract them first. A mononomial is an expression consisting of a number variable or product of numbers and variables that have whole number exponents. A mononomial has one term. The root mono means one. Terms of an expression are parts of the expression separated by plus or minus signs. And you've actually done this some in Math 1 before. So let's take a look at several examples of mononomials. Right? That has one term. X, that's one term. These are multiple examples. So I'm just writing, this would be a mononomial if you had minus 4xy by itself. And then I'm separating these with commas. That's a mononomial. So there's several examples. This would not be a mononomial. 4 plus x, or x minus 1. X squared plus 3, not mononomials. So a polynomial, right, that stands for more than one, can be a mononomial or the sum of mononomials classified by the number of terms. So most of our work in Math 2 is going to be dealing with polynomials, and that's just simply, it could be a mononomial, but typically it's more than one. So a mononomial, and these are kind of strange words to pronounce, has one term. Right? And we've done a lot of examples. X, Y, Z, 3, all one term. Binomial. Like bicycle has 2 tires, a binomial has 2 terms. Example, x plus 3, y plus 9, z minus 4. These are all binomials. And a trinomial has 3 terms, like a tricycle, 3 wheels. And x squared plus x plus 1, that's an example of a trinomial. X to the third minus x minus 3, there's another example. Polynomials are also classified by their degree. The degree of a polynomial is the greatest value among the sums of the exponents on the variables in each term. So let's take a look at some examples. So in this, they're looking at this particular term, and this is a binomial. And I'm going to have trouble spelling this. Let me see. Binomial. That's supposed to be an I. And right, the sum of the terms of the exponents here is, this is the one we're looking at. Right, what is the sum of the exponents? So this is a 6th degree binomial. And this next thing, right, has 3 terms. There's a term, there's a term, there's a term. These are all terms. And so this is a trinomial. And we're just basically learning what to call these things, right? So that when we have conversations about it, we at least know what we're talking about with each other. So that's kind of the rationale behind learning a lot of this vocabulary. It's just, when you're talking with your fellow mathematicians, we all know what we're talking about. And this trinomial, right, we look at the greatest value among the sums of the exponents on the variables in each term. And so this particular trinomial has a term that's 2n to the third, right? That's the largest one. So that's a 3-degree polynomial. And here we go. There's a term. There's a term. There's a term. This is a trinomial. And it looks like the largest one here is this thing, 3x squared y squared. And the sum of those exponents makes this a 4-degree polynomial. Right, this is also a version of a polynomial, the first one, and here we have two terms. So that makes this a binomial. Now, monomials, binomials, and trinomials are all types of polynomials, right? And let's see, the sum of the largest degree. Well, let's see, if we took 8ab squared, right? There's really a 1 there. 2 plus 1. This is a 3-degree polynomial. So when a polynomial contains only one variable, there's a standard form in which they are written. The standard form of a polynomial as written with the terms in order of decreasing degree. So basically that's the complicated way of saying the stuff with the largest value of the exponents, that's what you put first. So for example, if I had, x squared plus x to the third plus x to the fourth, the standard form of this would be, right, what's the largest exponent? X to the fourth plus x to the third plus x squared. So it would be standard to list the terms in decreasing order, right? 4, 3, 2, and so on. So the first term is called the leading coefficient. And the leading coefficient in this example would be 1, right? It's 1x to the fourth. So you're going to have some more examples to make sense of all this. Give you a moment to write all this down. Most of this chapter, we're pretty much just adding and subtracting like terms. So I'm hoping if you haven't had much success in the previous test, this next test, this is going to be your test that you're going to do super well on. So hang in there. So here we go. Let's write these in standard form. So we've got all these terms, and standard form simply means, well, put the one with the biggest exponent first. Right? That's the one with the biggest exponent, x to the third. So I'm going to write that one first, because the standard way is just to list them in decreasing order. So I've got x to the third. Well, what's after 3 if I'm going in decreasing order? That would be 2. The next one, minus 2x squared. And then the one after that, plus 20x. And then the one after that, plus 1. So that's the standard form of basically this thing. And the leading coefficient simply says, well, what's the number in front of the variable on the very first term from standard form? And that makes our leading coefficient a -4. Now you'll recall coefficients from Math 1 are just the numbers in front of the variables. So, right, a lot of this vocabulary is just so we can converse with each other, of course, when we talk about math, which is often, right? That we all know what we're talking about. So, next up, well, what's the largest exponent? So I'm going to list that one first in standard form, minus z to the 6. Well, after 6 is 5, and then 4, but I don't have anything to the 5 or 4 exponent power, but I do have a 3. So then this is plus z to the 3rd, and then the last one, plus 4z. Now I put little dash marks through my z's, just a good habit, so I don't mix them up with 2's. And you've seen my handwriting, so every little bit helps me distinguish z's from 2's. Now the leading coefficient of this thing, we're talking about the first number in front of the largest powered exponent, variable with an exponent. That's a -1. And here we go. Let's keep sorting these out. The largest power, the exponent, then I'm going to list these in the largest order first, and then decreasing in value, 4x to the 3rd minus 3x squared plus 10. So we will be adding and subtracting this chapter. We'll also be like sorting these out into standard form. But hopefully you can see that's not very difficult to do. You just have to be able to recognize, x to the 5th is going to be a higher order polynomial than 4x to the 3rd. And the leading coefficient, right, the number in front of that variable is a 1. Here we go. Highest power minus 15x squared plus 10x plus 13. What's the number in front of the highest powered variable? -15. So that is the leading coefficient. Simplifying polynomials. Like terms. You've done this before. This is just like terms on steroids a little bit. Like terms are monomials that have the same variables raised to the same powers. Unlike terms have different powers. And I'm going to give you some basic examples. Right? If I have x squared plus 3x squared, these are like terms, and that's 4x squared. Right? 1 plus 3. But if I have x to the 3rd plus 2x squared, right? These are not like terms, right? Because there's not that the numbers are different, but the exponents are different. So this doesn't simplify. This simply is this. I cannot combine it any further. So I cannot, remember in like terms, you're trying to put them together. I'll give you another basic example. X plus X plus Y plus Y. These are like terms. Those are like terms. So all that is equal to 2X plus 2Y. Right? And that's in a nutshell what you're going to be doing in this chapter. Basically adding like terms or subtracting like terms. So here we go. Let's take a look at a sample problem here. Well, let's see. What are the like terms? We're going to rearrange them in decreasing order of exponents. So we've got something to the 3rd plus another 2y to the 3rd, right? So I've got this one and I've got this one. And then what's after y to the 3rd? We have y squared minus 8y squared plus y squared. So far, so good. We've just rearranged the order, and that's totally allowed. Now let's group the like terms in parentheses. Well, it appears minus 2y squared and plus 2y squared are the same term at least, y squared. And then I'm going to add that to, in parentheses, minus 8y squared plus y squared. And some of you are thinking ahead and, just doing this, adding these up and thinking these steps aren't important possibly. But I want you to go through the motions here of this if you're doing that, because the exercises we're going to do lead to future factoring abilities as the problems get more complicated. So just follow the steps and you'll see where I'm going with this in a little bit. So we've grouped the terms, the like terms in parentheses. Now what we're going to do is we're going to factor out their common term. So what is the common term here? That's y squared. So it's going to be y squared in parentheses minus 2 plus 2. And some of you might be going, what? Yes, you can factor this out. And if you were to redistribute this, you would get what's up above here. But I'm just going to pull out the y squared. Or y to the third, that is. Y to the third. And look at Minton's already making errors. Y to the third. Probably because I'm doing this at Sunday morning at 4 a.m. and I need some more coffee. Here we go. And then we're going to factor out the y squared here. Minus 8 plus 1. So, as you can see, right, this is going to be y to the third times 0 plus basically y squared times a negative 7. And your answer, once you've added all these together, is going to be minus 7y squared. And that's what happens when you add basically this whole mess together. So I'll give you a moment to write that down, and then we're going to move on to the next example. So on this this second example here, I want you to cross it out because I have a duplicate. And here's the example we are going to do. It is p squared q to the third minus 4 p to the fifth q to the fourth. And don't let all the p's, q's, and exponent powers freak you out. You are just basically adding and subtracting like terms. So there's the example. And now let's rearrange them in descending order of exponents. So let's see. I think we have p to the fifth is the highest power here. So minus 4 p to the fifth q to the fourth plus 3 p to the fifth q to the fourth. And then I have a plus p squared q to the third minus 4p squared q to the third. So I've rearranged them in descending order of exponents. Now I'm going to group the like terms in parentheses. Minus 4p to the fifth q to the fourth plus 3p to the fifth q to the fourth plus p squared q third minus 4p squared q to the third. Okay, and now I'm going to use the distributive property so I can pull out basically their common factor. The common factor. And let me use a different color to highlight basically what the common factor is. The common factor in these are these things. So I basically have p to the 5th power q to the 4th times minus 4 plus 3. And then I also have p squared q to the 3rd times basically 1 minus 4. And you'll see how when we factor stuff out, which is kind of why you want to engage in this practice, we are going to be factoring in about 2 more chapters. So let's baby steps factor now, so that when we do factor on the hard stuff, you'll already have experience doing it, and it won't be so difficult. So here we go. We factored out the common factor, and now we just have basically negative 4 plus 3. And what is that? That's a minus 1, right? So you're going to have a minus 1 times p to the 5th, q to the 4th, and then plus, what's 1 minus 4? That's basically minus 3 p squared q to the 3rd. And this is simplified. I can get rid of this plus sign, but that's the final answer when you add this whole mess together. And hopefully this factoring step makes it look a lot easier. And now let's try this next one. Rearrange in descending order the exponents. Well, the stuff to the 2nd power appears to be my highest power. So here we go. 3p squared q squared minus 3p squared q squared minus 3. Oh, you know what? That q to the 3rd is actually higher. You're going to kill me. So I'm going to start there. Or if you did that already, just add that next. It's not that big a deal. 3 squared q to the 3rd. And then plus 3p squared q squared minus 3p squared q squared plus pq. Okay, now let's group the like terms in parentheses. So there is nothing else with that. But there's this, 3p squared q squared. These are like terms. So those are the only like terms we have. Use the distributive property. We're going to factor out that common term. And inside you have basically 3 minus 3. And right, what is 3 minus 3? That's 0. And 0 times p squared q squared is simply 0. So then this simplifies to negative 3 p squared q to the 3rd plus pq. So there's some examples. We've already done some examples in a starting worksheet. And that's your notes for this section. We're going to work on some stuff from the textbook now.